Here we have a rod which is indicated by a bluish green color here like this, and this rod is resting against a wall. Okay, now this rod has 2 points. This is A point and this is B point. Suppose this A point is pulled with a certain velocity, let's say u, then we have to find out what will be the velocity of the end B. Okay, so now to find out that, we have to use the constraint. Okay, now let's assume that this rod was making an angle theta at a certain time, okay, when it is having a velocity u. So this angle is theta. So now what we have to do, we have to take into account the velocity component of the point A in the direction of this rigid rod. Okay, like in this way there will be one component. Okay, let me draw it little bigger so you can see properly. So this is like this, this is along the rod. Okay, and this particular B velocity will be like downwards. Okay, so this is the velocity downwards, but the velocities component along the rod, okay, here I am showing this component along the rod will be like this, and another component will be like this. Okay, so here also this will have another component like this. So this is the original velocity vector u, which is towards left, and its two components are this one and this one. Now at a certain time it makes angle theta. Now what will happen, suppose I resolve this u vector in two components. So this angle will be theta because this is vertically opposite angle to this one. So this is u cos theta. So this is the component of along the rod, and let's say this velocity of this B point is v. So this angle will be 90 minus theta and this angle will be theta. So here this component will be v sine theta. Okay, now the component u cos theta and v sine theta of these points A and B must be same. Why? Because it is a rigid body. So this is a rigid rod. So for example, if I have a rigid body like this, suppose a book is there like this, if I push this book towards left with a force, suppose, okay, and as a result it starts moving on a frictionless surface, then this particular end of the book is moving with 0.5 meter per second speed, then this particular end will also move with the same speed. This is the rigid body constraint. That means all the parts or all the points of the rigid body will move with the same speed. So here also this constraint we will apply. That means this particular component of the point B and this particular component, that is the u cos theta of point A, will be same. So v sine theta will be equal to u cos theta. So what is the value of v? Value of v is u times cot theta. So if you pull the end A with the velocity u, then the point B will go down with the velocity u cot theta.